Right, hello everyone on this evening even, and this is my first time doing a severe weather update, as opposed to normally what I do is the tropical weather updates. You've probably seen a lot of them already on the channel that I try to focus and basically focus my resources on tropical meteorology, but I do a lot of the severe meteorology in the background. I never really ever have made an update on it, so this is my first time actually doing this. Hopefully it will become useful and more sophisticated in the future when I make more bulletins on more significant outlooks as the year progresses into the actual tornado season itself, and even currently we're in the Dixie season. And so I want to start this off and see how this will go in the future. And if you do like to see these updates, and if you do find them useful for understanding the severe weather meteorology, then you can let us know in the comment section or anywhere else. Alright, so today we do have a slight risk in the region here in the northern and central Louisiana, all the way to the western Mississippi region, and we're going to read the SPC outlook today, and we're going to look through the different soundings, the environmental soundings within the main corridor of risk, which we're going to first represent through the outlooks. So we have a 5% tornado risk, which is why I'm perceiving this like as a useful video to make, so we can update on this. So we've got a 5% tornado risk, and the same slight risk in the northern to central Louisiana to western Mississippi, and then we have wind risk in the exact same region of 15%. Non-significant, no hatch. Hatch usually means that there will be significant winds of greater than 75 miles per hour, and in that particular region. Hail, we do not have a significant threat. So today's SPC has reading. Its values from today 4:30Z to 12Z, and so there is a slight risk, and the main summary is strong isolated severe storms will be possible today and tonight from eastern portions of Texas towards Texas eastward across the lower Mississippi Valley, Louisiana to Mississippi. Morning water vapor imagery shows deep upper low over southeast Colorado with a band of strong southwesterly flow aloft extending across central Texas. A cold front is sweeping eastward across East Texas into a moist but only marginally unstable air mass across Ark-La-Tex region. The result is likely to be continued risk of showers and thunderstorms along behind the front. Forecast soundings throughout the prefrontal region show strong low-level shear and deep-level shear, providing favorable conditional environment for organized convection updraft rotation. The primary concern is weak force in the warm sector and the weak thermodynamic profiles. These factors suggest storms along the immediate front may become strong, severe, but it is uncertain how long these storms can remain surface-based and before being undercut by the front. Nevertheless, the strongest cells should produce damaging wind dust or tornado through the afternoon and evening. And so we're going to look into the actual outlook. So we're going to use this to do our analysis on what the event is going to produce. And so this is the temperature map that will show the temperature lines and these pressure grid lines, these isobars, and they will represent the surface pattern. So this is going to be progressing from 12Z to 0Z, and you can see this circular feature along this region right before and leading ahead into the region. This is going to be our surface low pattern, and this is what is going to represent the reason for the threat that the SPC has provided. Okay, and now we are going to look into more detailed the environmental sounding. So this is going to be the moisture graph, and this is where we take the sounding and the soundings will represent the exact environmental conditions, and that's the main analysis that I'm going to provide. Alright, so this is the first, and this is the peak sounding hours for the represented SPC risk. So as of this sounding, we can clearly see the thermodynamic profile on the left and the kinematic profile on the east, on the right hand side. And so we have a tornado risk, and so with this sounding on the thermodynamic side, we have marginal instability, and that is represented through the mixed layer Cape value of 650 and a maximum unstable of 746. So we have a low range, and this could be slightly undone, but these are the current values to represent this. So, and then now we have on the thermal line, we have the lapse rates, and this is the mid-level lapse rate between 700 and 500 millibar of 7.4 degrees Celsius per kilometer, which is within the favorable region. And in the lowest levels we have around 6.4 to 6.8 degrees Celsius. And we're going to be looking at the significant things that will cause the effect and will produce a more significant thermodynamic profile, and that will be the 3 Cape. And the 3 Cape is currently within 34 joules per kilogram, which is just below a minimum margin, roughly estimated at 50, and this is going to be just enough to produce potential isolated tornado threat. We have a D Cape of 415, which means that the updrafts that do develop will essentially have the chance to cause by evaporative cooling to bring down the strongest winds from aloft, and we have about 415 joules per kilogram, but this value is slightly in the low end, so that suggests that which represents the SPC risk of only being a non-hatched 15%, as it's unlikely, but it's still a potential risk for strong winds to be produced from the severe thunderstorms, likely around 60 mile per hour, the minimum, and could be increasing. Now, also, we're looking at the upper level of that sounding. So we have a fairly we have a separated dew point and thermal line, but we have a little bit of saturations in some of the levels that could be partially an issue, and that could represent like some sort of cloud tops, some sort of cirrus or some sort of layer that could be producing and could sap the instability into certain layers of the atmosphere, and that is a potential likelihood, as in the Dixie season, late season, we have the Louisiana Gulf Coast, which has bayous, and these bayous cool, and when they cool, they produce these cirrus clouds that can undercut the instability values, which is going to be represented through this region, this region, but outside of the thermal line, but to the left of the partial trace, and that is the instability that can be cut off due to that low cirrus layer, or even the higher clouds that are produced from that cooler waters coming over the surface of Louisiana, central Louisiana, where the instability is expected, and that may temper severe threat. And now on the kinematic side, there is the reason for the tornado 5% risk, mainly provided by the kinematics. We have a strong veering between the 1000 to the 850 millibar, where we have southerlies to southwesterlies, and we increase significantly from 15 to even 40 knots and above, and then it continues increasing with the strongest deep layer shear above that 700 millibar range. And then this is the hodograph, which is now going to represent so this is going to be the storm motion, and we're going to have the curvature represented from this diagram here onto a graph. and what we're going to see is the low level shear in the purple trace, and then the mid levels, and then the upper levels. And you can see this part here is representing through this SRH values in the meters per second, meter squared per second squared, and we have an effective inflow layer which is going to be from this motion all day to the left. Here, this blue line is going to represent that, which of significance, which to become significant would require at least above 100 meters squared per second squared, and here the values are exceeding 390, specifically 292 meters squared per second squared, which is significant for the range for severe threats, and is in the moderate to high range. And then we have this sort of backing in this region right here, which can allow for some ventilation and allow for persistence of updrafts that do develop in the mesocyclonic region, and help it increase its longevity and its structure such that it can provide that tornadogenesis to occur. And then we have this deep layer shear that extends upwards, which also helps shunt the precipitation ahead. We have effective bulk shear values, which will represent the values up here at 55 knots, which is much more significant than the minimum values usually required, above 25 to 30 knots. So the plenty of the forcing, allowing for the initiation of convection. And the main four factors usually, I should have mentioned this before, is the moisture, the instability, the wind shear, and then the ability to allow for initiation of convection. And here we have a slightly saturated profile, and one of the things is the initiation. So alright, so we have the convection initiation coming from the southwesterly angle, and the cold front in this same angle along this line will mean that the southwesterly will become more parallel to that vector direction. And so what that means for the initiation of convection is that we're going to see this linear convection where the single cells produce multi-cells that come from the southwesterly to the northeasterly and collide into each other, producing a linear line type segment. And so we can see bow echo segments that are essentially representative of more of a line, although that does not necessarily mean that that can be isolated, embedded, and ahead of supercellular convection, which is going to be the significant tornado risk that is represented. And just to keep the consistency in the hours prior in the same region, we are seeing the same sort of sounding to confirm our sounding analysis is given the correct and valid data. Alright, so this is going to be the update that I have. I really do like to do the sounding updates, because I think it's better to represent and teach and inform and even learn about what the environment is going on, and I have a better understanding of those sorts of parts of the same meteorology updates that I can provide. And so yeah, I hope that is useful for the future updates that I can provide. With that, I'll see you guys with the next future update, and we will also see potentially if anything does happen from the aftermath of the outbreak. We can do a post-analysis video just to represent the soundings and what could actually come into fruition.